All right, good morning, everyone. Sorry that I'm late. My printer did not want to work at all, so anyway. How is everyone doing? Good? All right, good. Do you have a good break? Ish? Yeah. Anyone still eating leftovers? Yeah, I am. I'm so excited. I've had leftovers like every single day, and then I brought it for lunch for like the rest of this week. I'm pumped. I love leftovers. Okay. Do we have any questions before we get started? All right. So as you can see, we're going to go over the rules for our note cards. So this is the only note card. This will also be posted. You can take pictures. That's fine. I just saw like a bunch of people like panic picture. So this will get posted with our lecture notes. But I mean, you can also take pictures if you want. That's totally fine. You can only use this note card. So the reason that it's colored is so that I can easily identify during the exam to be like, yes, these are the OK note cards. The reason that it has to be this note card is to make sure that everyone is given the same size note card. That way no one's trying to sneak in like a 3.5 by 5 or something that they tried to make on their own. So it must be this note card, and I am going to initial in the upper right-hand corner to signify that it is my note card. If you are taking the exam at SLDS or the testing center, they both know that this is the note card to look for and that this is what will be accepted. So you'll be able to use it. They know this. I do this every time for all my Orgo 1 and Orgo 2 classes. All right, so it must be that note card. You cannot have any other note card. Because I only have this many of them, that means that each person can only get one because I don't have enough for everyone to get two. So you want to make sure you take very good care of this. I've had people lose it. That really sucks. I've had people spill their coffee on it. That's also a bummer, but at least you still have it. I had one person's significant other be very sweet and write, "I love you," all over it. They needed a lot of whiteout. Take care of it. You only get one. I only have enough for each person to get one. So if you don't want to pick it up today because you're afraid of losing it, that's also okay. You can pick it up on Wednesday after lecture in office hours. I will also post my availability for the rest of the week in case you know that you're the type of person that you're like, I'm going to lose that. Wait then. But I will have it available all this week for you to pick up, and I'll also have it available right before the final exam. You must write your initials in the upper left-hand corner. So I'm going to write mine in the upper right. You will write yours in the upper left. The point of that is to make sure that your note card gets back to you. So I want you to come pick these up later because my hope is that what you summarize on this note card will then be a good resource for you in Orgo 2. So I want you to utilize this as a resource in the future. So instead of having to go through all of your notes, you can use this as your quick guide to be like, you know, what were my addition reactions again, or whatever. So I want you to put your initials on it to make sure that we can get it back to you. So in case it gets separated from your final exam, then make sure that we can make sure that you still get it. You may write on the front and the back of the card. Totally cool. Everything must be handwritten. So you may not print on it. You may not attach anything to the card. You may have someone else write on the card for you. This rule got added a couple of years ago when I had one student that broke their dominant hand right before the final. So then they were like, I can't write. So that student, which they ended up getting SLDS accommodations and everything so that they could have someone help them. But so from then on, I said, okay, I don't care who writes on it. It just must be handwritten. I will say, though, if you get someone else to write on it for you, make sure you tell them what to write, because otherwise it's not going to be as useful to you, because the major complaint that students will have about the note card is that they will spend a significant amount of time during the final exam looking for the information on the note card. And so you'd want it to be a useful resource, not a hindrance during the test. So make sure you know what's on it and where everything is on it. You may write literally anything on the card. Everything is fair game. So you may write quiz questions and quiz answers if you want. You can write homework questions. A lot of students will do like reaction roadmaps, or they'll do just a list of their reagents. You can write anything you want on it. It could be words of affirmation, like reminding yourself that you know this. Whatever you want. It is all fair game. It is your card to write anything you think will be useful on the final exam for you. You may use any writing implement as long as it is not a printer. So any colors, whatever you want, pen, pencil, highlighters, whatever. That's all fair game. I will warn about pen that you only get one. So if you have pen, make sure you also have whiteout in case, or like one of those pens that erase in case you write something that you don't want. You must turn your index card in with your final exam. This is done to ensure that you don't write questions from the final exam on the note card, take it with you, and then tell other people what the questions are, in case anyone is taking it not at the same time as everyone else. But I do want you to get the card back. So I do want you to come back once the final exam is graded, get your final exam, take your note card, and I want you to use it as a resource in the future. Only you may use your note card. So don't think that you'll sit next to someone and be clever and be like, all right, you write the first half, I'll write the second half, and then we'll switch note cards in the middle. No, that is academic misconduct. You may only use your note card. You may not share with anyone else. You can't take it with you and then give it to someone else. It's meant to be a resource. So use it to help you, and yeah. All other materials will be confiscated. So meaning you can't add any notes or extra pages. If you do attach anything, we rip it off, we take it away. So don't do that. All right. Are there any questions about the note card? Cool. All right, so we're not going to do it now because it takes quite a bit of time. But at the end of lecture, and then during office hours as well, so if you go to office hours, it might be easier just to get it in office hours. But at the end of lecture, I'll pass them out. You will just need to initial your, next to your name. So you'll find your name, it's alphabetical by last name. It's my way of making sure that you get only one. And so you'll just say that you picked it up, and then you'll take your note card. Oh, the other thing, you may not pick it up for anyone else. I've had an issue in the past where someone picked it up for a friend and then they lost it. I don't have enough for everyone to get two, so I can't give anyone two. So that means I don't allow anyone to pick it up for a friend. You must actually pick it up. So you pick up your note card, you sign for yourself, and that is it. Okay. Now, are there any other questions now that we've said that? Cool. All right. Oh, it's not on here. I thought it was on here. Well, we'll look at this anyway. So we are currently right here. So we're going to finish our Diels-Alder discussion, and we will either start, or we'll probably also finish our chapter 3 content. Since we've seemed to enjoy having more than just the 55-minute review session, I was thinking that I would also hold a review session on Thursday, if that is something people want. Okay, so then that also makes me feel better that I don't have to rush. So I will have whatever we don't finish today, we'll finish on Wednesday, and then we'll have like a 2.5-hour or 3-hour review session on Thursday. It'll be via Zoom, it'll be recorded, so you can come and go. It'll be like the other ones, so that it'll be posted. So if you can't attend, it'll still be recorded. And we'll go over the summer session final exam, because that's what your exam is going to be most similar to, again, in format. Okay. The informed consent survey, remember that this is the only survey that isn't mandatory. So this one, doesn't matter if you finished it or not. If you did not finish the post-course survey, if you forgot, that is okay. I'm accepting them late. Still do it though. And it has to be done before the final exam. So do it as soon as possible. I will send out completion data probably on Wednesday. just to let you know and give you a couple more days to complete it. But yeah, please do it. And you should have received a confirmation email saying that you did complete it. If you didn't receive the confirmation email, let me know. But you should have had that, and that can be your like extra double check to make sure that like you have everything. Your last homework is due on Wednesday. This homework cannot be turned in late. So the reason that it cannot be turned in late is because our course coordinator is going to start processing grades on Thursday. So that means that basically Thursday morning, I have to go through and make sure the entire grade book is absolutely ready. There are no missing grades. Everything is good unless you have an incomplete. But I'm gonna make sure that every grade is set and will not change. And then I will hand it off to the course coordinator and she will start processing it. So that way the only thing missing is the final exam to try to make sure that you get your final grades as fast as possible. So that way you get it as soon after the final exam as possible. So make sure that all of your homeworks are completed by Wednesday, 11:59 p.m. Eastern. They cannot be turned in late. Our SEI is due, oh, I made the extra credit due on Thursday. Well, that was silly. All right, I'll have to tell her to wait. Okay. Whoops. All right, well, do the extra credit as well. It's due on Thursday. And yeah, I'll just have to let her know I messed up. That's fine. The extra credit is due on Thursday. Make sure that you complete it. And yeah, that just means we get a little bit of wiggle room. So in that case, you can turn in your homework one day late. But it can't be after Thursday because I'm going to get in trouble. Yeah, so your homework, it'll still be late. So there'll still be the penalty, but it'll be accepted one day late. Extra credit is due on Thursday. Your SEI is also due on Thursday, I believe, either Wednesday or Thursday. Please complete them. So the student, I can remember what evaluation of instruction. There we go. The student evaluation of instruction, your SEI, it's your feedback. It is very, very important to me. I read every single one of them. So it is very valuable feedback for me to make sure that I am teaching the course in the best way possible and improving my teaching style every semester as I go. It lets me know what works well and what doesn't. So like, I really appreciate honest feedback. It is extremely valuable to me. So please do fill it out. And as an extra incentive, yeah, I'm gonna do this. It's very, very important to me. So if 80% of the class fills out the SEI, everyone will get 5 bonus points on the final. So hopefully that now makes it worth your time, because I know going into final exams, like, your time is limited, your time is very valuable, especially with everything else that I have due this week. Like, I get it. So yeah, you'll get 5. Actually, I'm gonna make it even more valuable. I'm gonna make it 10 points. You get 10 bonus points. Like, I'm really serious. Like, it really is important to me. So I really want you to do it. So that'll get you 10 extra credit points on the final exam. And because it's all anonymous, and it really is 100% anonymous, I have no clue who does it, it's just a number, it'll just have to be an 80% threshold. If you hit that 80% threshold as a class, everyone will get the 10 bonus points as a reward. So yeah, just please do fill it out. It's very important to me. However much time you can spend on it is perfect. If you can't fill out the open-ended section, that's fine. Although I do really value the open-ended section, but yeah, please do fill it out. It's very important to me. So yeah. All right. Any questions about the plan for this week? Yeah. Yes, yes, I will make an announcement. That is an excellent point that 80% of the class does not attend lecture. Yeah. I'll post an announcement. Yes. Yes, all of the regrade exams, I have them on me. They are all ready. If you did not see a comment, then talk to me, because that means that your TA did not give me your exam. So every single exam that I have at this point has finally received a comment on Canvas, meaning that your exam is now ready for pickup from me for the exam regrades. Any other questions? Yes. For the informed consent, no, you won't get an email for that unless you want one. I wasn't gonna, because it's not required. If you want one, sure, yeah, I can do that, sure. Yes. The post-course survey, no, I have not gotten the data for that yet. I will do that on Wednesday. Any other questions? All right, cool. Thank you for bearing with me as we did all the announcements. It's just, with 1 week left, I want to make sure that we all know what's going on. Also, actually, one last thing. Our final exam is on Monday, so it's a week from today. It is at 10 a.m., and it's in this class. So it's in our regular classroom, which does also mean that that kind of sucks, because as we remember how jammed we were at the beginning of the semester, we're going to be pretty packed full again. But we technically all fit, so we will do our best. But it'll be in this room at 10 a.m. on next Monday. Right. Any last minute questions about logistics? Sweet. Let's finish out this Diels-Alder notes then. Okay. So we left off talking about endo and exo. And so we had said that when we form bicycles, when we're getting that fused ring system, it was when either our diene or dienophile was a ring initially. And so then to tell how we break it apart was that you again look at your double bond, then you go 1 carbon away. That's your disconnect to find your original diene. And then the other part is your dienophile. So you could imagine like you're pushing the bonds around like that, essentially, to have it close down. Or you could imagine how our reaction actually would be like this for our curved arrows. Why did I have to change the curved arrows? Why did they have to go clockwise instead of counterclockwise? Yeah. Yeah, that top carbon is more electrophilic. So remember that your methyls are electron donating groups. That makes the bottom carbon delta negative. So then that partial negative charge. So the more electrophilic side is the top carbon. We can't forget the electronics of our dienes and dienophiles. Okay. So the concept of endo and exo is talking about if you are on the same side or the opposite side as that double bond, as that like alkene bridge. So if you are endo, you are on the same side. If you are exo, meaning like outside, then you're like outside that. So it's looking at comparing these two bridges, like this bridge and this bridge. The one that is closer to the double bond bridge is endo. So this side becomes endo. The one that's closer to the other bridge is now exo, right? So that's that relationship. Is endo is going to be closer to the double bond bridge. Exo is where you're farther away. All right. So then if I look at this product, would you describe this product as endo or exo? Endo. So the R groups are going to be on the same side as that double bond, right? They're closer to the double bond ring or double bond bridge as opposed to the other bridge. So that makes them endo. So then how would you describe this product? Exo. All right. Here, we're going to assume R is an electron withdrawing group. So we're defining it to be some electron withdrawing group. So it could be like an aldehyde, an ester, a ketone, nitrile, a CF3 group, whatever. They're a halogen. They are the electron withdrawing groups. That is going to favor the endo position. So when they are electron withdrawing groups, that helps favor the endo product. The reason why is because the transition state is going to be lower in energy. Essentially, when they're down here, it's kind of poorly drawn. But if you were to actually draw out the orbitals, like you get orbitals parallel to each other if this is like a carbonyl. So like if that's a ketone, they're actually closer in proximity than my drawing indicates. So that is going to actually lower the energy of that pi bond that is being formed. So it lowers the whole energy of the transition state. So it's just faster. So when these are electron withdrawing groups, endo is preferred. And again, actually, I'm just going to write this out so you have a written definition. So endo is saying that the groups are on the same side as the alkene bridge. Exo is where the groups are on the opposite side. Of the alkene bridge. And when the group is an electron withdrawing group, which is what we typically see on our dienophile, right? Because it's the electrophile. So normally we want this to have electron withdrawing groups. That's what made it faster in general. So that's usually what we see. We typically see it with electron withdrawing groups. So then endo usually is the product that you're going to see in general anyway. All right. So then we're going to predict our product then. So looking at this, I see that this is going to be my diene because I see the two alkenes, the diene, two alkenes. That makes this one on the right my dienophile, which also tracks because those aldehydes are electron withdrawing groups, right? They're making this more electrophilic. So when I go to draw this, let's number these. I make this 1, 2, 3, 4, 5, and then 6, 7. I am going to be connecting 1 to 7 and 4 to 6. Since this is a cis dienophile, I need my substituents to end up on the same side in the product, right? Because the cis dienophile goes to the cis substituted ring. So if they start on the same side, they end on the same side. So the easiest way for me to draw my bridge, recognizing that I'm essentially just gonna like fold this flap up, is I like to start in the like upper, actually wait, how do I do this? I lied. That's not where I like to start. I like to start in the upper left corner. So I draw the line going down, across, and then up as a really long bond. because then I can draw the one under it having that little break in it. So the alternative way would be to just like draw it that way and then erase to give the little gap to show what's in the front and the back. So that comes down. So this is 1, 2, wow, that's a really rough looking ring, but whatever, 3, 4, 5. So then this is 6 and 7. I gotta fix this ring. It's too atrocious. So there's my 6 and my 7. So then my aldehydes go on the bottom, because it needs to be endo as my major. Actually, let me write it this way. Cis is required. Endo equals major. Because the minor product will be that enantiomer. Well, yeah, will be the enantiomer. The major is the endo. The minor is the exo. It must be cis, though. You cannot get that trans relationship if you start with a cis dienophile. All right, so go ahead and try to draw the product for the next one. Did you draw two structures? Because we have to draw our enantiomer. The trans dienophile leads to the trans product, and I can get the mixture of enantiomers now. Because one will always be endo. The other one, I don't have a choice. It has to be exo because it has to stay trans. So we'd have to draw the two products. To draw this planar, so that's our three-dimensional structure. It's easiest if you do the six-membered ring as your planar hexagon. So then I get my alkene between 2 and 3 still. To show the connection up to the methylene, the CH2, carbon 5, because it's up, I show the wedges coming together. So I show the two wedges coming up, and then I get, this one has the CHO, the aldehyde is up, and then this aldehyde is down. for this structure, this is actually a diastereomer, that's not the enantiomer, as I'm drawing it. Let me prove the point up here. Having fewer options will probably make it a little bit easier. Okay, let's switch colors to try to highlight it. All right, so I can have that wedged bridge head, or bridge, sorry. And then I had my aldehydes endo. The enantiomer of that is actually where I invert everything. Dashes look a little wonky. What do we notice about the enantiomer? It's just flipped over, right? So in this case, they are actually the exact same molecule. Which is why all I drew was that. Because to draw the enantiomer, it actually is the exact same molecule for this one, for that bridge. So just be aware of, we still need to pay attention to our stereochemistry. And we're going to see the same thing, that when we flip these over, that we're actually going to get the exact same structure back. So it worked out. But that's why we're only drawing 2 of them. Sorry. All right. Does endo and exo make sense, though? That's what I was hoping we would get across for that. So any electron withdrawing group, it wants to be on the same side as the alkene bridge, because that's going to stabilize your transition state. All right, so when we're combining this, if you have endo and exo, I'm assuming that your ring is connecting your eyes. And so this is going to summarize all of our options for the diene chemistry, dienophile chemistry, endo, exo, everything gets summarized here. So looking at my diene, my S-cis diene, remember that it's S-cis because that's talking about the sigma bond. So my 2 alkenes are pointing in the same side relative to that sigma bond. I get this inside-outside relationship. So the O is representing outside. The I is representing inside. So that is talking about the cis side for inside. The outside is that trans relative to this bond. Relative to that sigma bond. So it actually isn't cis or trans, it'd be E or Z or whatever, depending on what's there. But it's talking about if it's on the inside, meaning the same side, it's pointed inwards, so that it's like, when I had my hands out and I reach for that stick thing, it would be like my thumbs are the inside, and then my pinkies are the outside, right? Because it's just, those are my 2 substituents, so the ones that are coming in are my thumbs, that's the inside. All right. So that's why I was saying that if you're assuming a ring, like when we had our 5-membered ring, the inside would have been connected, in which case then you get endo and exo. so that when you have those as your wedges, then you get the endo as the dashes, and then your exo are wedges on the same side as the smaller bridge, right? So we can get this general summary where if you do this assignment, we can rationalize these products for all of our dienes and dienophiles, remembering that it's always plus the enantiomer. But this also helps us recognize that even if it isn't connected, even if it isn't a ring, I still will always get whatever is inside, whatever's pointing, the thumbs always end up on the same side. Your pinkies always end up on the same side. The insides are the same side, outsides are the same side. Plus that enantiomer, which actually I'm going to draw out because in previous semesters it tripped people up. So if this is O, that's I, that's O, that's I. So now my endo is the wedge, my exo is the dash. We're ending up on the opposite side of whatever's pointing towards the inside for that endo position. And when the electron withdrawing group is attached, endo is favored. For our electron donating groups, they will always be exo, but that is generally disfavored. And so what I should say is disfavored because less electrophilic. Your electron donating groups will go exo, that's what they do, but it is generally disfavored because now your dienophile is less electrophilic. So it's slower. Okay. When we talk about our regiochemistry, we already did this actually. We need to make sure that we pay attention to our nucleophilic and electrophilic sites. So when I look at this methoxy group, is that going to be electron donating or electron withdrawing? Let me put it this way. Does it have resonance? Yes. So if I have resonance, then draw the resonance structure, right? To know. So when I draw that resonance structure, do I end up with a negative or a positive charge in my diene system? Yeah. I get a negative charge, right? I have a lone pair next to a pi bond. So that means that I start at the lone pair and I push in, right? So then you get negative charges. So if I'm getting negative charges, I'm pushing down into the diene system. Is it electron donating or electron withdrawing? Electron donating, because it's pushing in. So it's electron donating group via resonance. So when we get our resonance structure, the relevant resonance structure, which is where I look at that reactive site, one of the reactive ends, that indicates that this carbon is my nucleophilic carbon, right? So then I know that this is where my curved arrows are actually going to have to start. Come out from that pi bond, all right? Now, looking at my dienophile, is this going to be this ester? Is that an electron donating or electron withdrawing group? Is there resonance? Yes. So what does the resonance structure look like? When I have the pi bond, so it's pulling away, you always go towards the more electronegative atom, give the electronegative atom its electron density. So trying to look at what happens on those two reactive carbons, I get the resonance structure. Where I get that positive charge on that carbon. So is it electron donating or electron withdrawing? Withdrawing, it's pulling it away. So it's withdrawing it away from that pi bond. So that ester is an electron withdrawing group via resonance. So that shows me that this carbon on the end is my delta positive. And again, we're just assigning the charges. I really only care about these because those are the ones that are making the new bonds. So then that shows me that this arrangement works because that has my nucleophilic side and my electrophilic side matching up. It is a matching set. Whereas if I flipped that dienophile over, which you always want to consider, it is possible. Now they are mismatched. Now I have the regions where I have less electron density next to each other and the regions where I have more electron density next to each other. So that is not going to happen. That regioselectivity does not work. They repel. So that means that we see the ester end up at the 1,2 position, like next to your ether. Not there, right? So the electronics are controlling the regioselectivity, where that group went. Bless you. So when I look at moving my electron donating group over one, so that it's no longer on the terminal carbon, instead of on the end, it's now in the middle. When I draw that resonance structure, I now see that that top carbon is my nucleophilic site. So then the other one has to be my electrophilic site. And then we already did this for the ester, so we know that matches up. So now again, the charges are mismatched. So now I have to flip my dienophile over for that reactivity to work. So now the only product that I see, my OMe is attached to the alkene because it's on that internal carbon. And that CO2Me is there. The ester is then on that site. So the electronics are going to control the regioselectivity. Does that still make sense? Okay. Any questions about that? All right. Then we're going to practice some exam style questions to say what are the products or What are the products? So we're going to rationalize our product formation. So for this first one, I gave you the product. Prove to me why this is right. So this would be an example of I would have given you a different product, and it would have been like, find the error. And so then instead, we're going to rationalize to ourselves that every aspect is correct, that all the stereochemistry, all the connectivity, all the bond connections, everything is in the correct location. The regioselectivity, every aspect is right. For the sake of time, I'm going to kind of walk us through, but hopefully you've had a moment to kind of think of at least parts of it. So first thing that we want to recognize is that I see the bond being formed there. So this is 1, 2, 3, 4, and then I have 5, 6. And I know that that 4 is connected to 5 and 1 is connected to 6 because my nucleophilic site of my diene is carbon 4. My electrophilic site is carbon 5 of my dienophile. So then I get those opposite charges. So that's how I know 4 connects to 5 and 1 connects to 6. Because that is the correct regioselectivity for the electronics. So it's the correct regioselectivity because we consider the electronics of our starting materials. Then I know that these are going to be dashes. We know that it's a dash because these are both outsides. So it's the dash because it's the outside. And then we're going to make this one a dash because endo is going to be more stable. So it's more stable when this is underneath that diene. So if I gave this to you as a, what's the error? What is wrong with this product? Yeah. There's no enantiomer. Beautiful. So what's missing is that you would also need the enantiomer because now my enantiomer is not the same, right? Because I have all different groups all throughout. If I turn each of these into wedges, they actually are 2 different molecules, right? It's not just the same thing flipped over, unlike the other ones. So the only thing missing is plus enantiomer. Okay. So go ahead and try to, now we'll do it all together. All right, so we're going to draw the product of this reaction. So we need to remember what functional group is this? think I heard it. Ester, yeah. So that's our ester. So how to use context clues is, and this will be the kind of thing that like I want you to do on an exam. Like I want you to be critical thinkers. So in case you forget, look around and try to see like, is there anything that might do a translate? Don't look in the find the error section because then it could be wrong. But looking everywhere else, then it might help you see the abbreviation correctly. So that we see that CO2Me, when it gets written out, it's this. That is my ester because I have the carbonyl with an oxygen on one side and a carbon on the other, or the OMe on one side. So this is an ester. So that's going to make this my delta positive, this my delta negative. This ether is going to be my electron donating group via resonance. So I'm going to get this relative electronics. So it tells me that I need to connect this carbon to that carbon, and then this carbon to that carbon. I recognize that these are both rings, so I'm going to have to draw a bicycle, right? Because if either my dienophile or my diene is a ring, I end up with a bicycle. So easiest thing is to make your diene be on that left-hand side, especially with the 5-membered ring, because now we've drawn it a bunch of times. So then if I make this, I'll make that the dots, and I'll make these the circles. So then my methyl is back on that bridge head on the back side. My methoxy is on the bridge head on the front side. Then my ester, I want that going down so that it's endo. So then my ring must be up to be the exo. Okay. All right. We will do radicals on Wednesday. It's going to be super short. We're only going to do like bare minimum of what we need. It's pretty fast anyway, but we'll do that, and then we'll do looking over the study guide, and I hope you all have a wonderful day.